Hey guys, it's Jake again with another video. This time I'm going to show you how to make a camera that follows the player with a dead zone, so that the camera only moves when the player reaches a certain distance from the edge of the screen. I'm going to show a quick sample of what I'm talking about with a clip from Super Mario World, so here you go. So here is Super Mario. Everybody's familiar with this, and you can see that as he moves um, in the middle of the screen, the camera doesn't follow him until he's moved a certain distance. So we're going to try to achieve a similar effect. And so I've already got a movement script attached to my player, which I'll include in the description. It's pretty basic, so it's not the best script in the world. There are better movement scripts, but this is just, I'm not demonstrating this, I'm just demonstrating the camera thing. So any movement script that you use will still work with this camera movement. So there's that. Like I said, it'll be in the description if you want to use that. These assets, I didn't make them, I just got them from the internet, and they're not fancy or anything. One of them's got the watermark there, so yeah, there'll be links for those in the description as well. And like I said, they're not mine, so I'm not trying to steal them or whatever. But anyway, so we've got our pirate ship, and I guess something I'm going to show you really quickly how to do, because I think it's useful, is how to just make a transparent image with a transparent background. So if you've got an image that has a transparent background, you can go cut out and use one of these things. I usually just use diffuse. So you go to into your, here, I'll show you step by step here. So in your shader on your material, you click that, you pick transparent, cut out, and diffuse, and we'll see that this becomes transparent. So now we've got our pirate ship. So basically we've got the character movement script done, and it just moves the character around the screen like that, but we can go off the screen, camera doesn't follow it, and that's not very good. So we're going to write a script that makes the camera follow the player, but like I said, there's going to be a dead zone in the middle. So we're going to create a new script. We'll call it camera controller. See if I can do this really quickly tonight without messing up too badly. Okay, so the first thing we're going to need is our character. So, and we're going to need something that has a transform. So we're going to say serialize field, and it's going to be a transform, and we're going to call it character. And then we're also going to need a temporary variable to hold our location as like an intermediate variable to hold our location so that we can move our camera, because Unity doesn't like it when you move things directly for whatever reason. So we're going to just go ahead and make another one. We'll make this one private. It's going to be a vector3, and we're going to call it move temp. And I guess we'll also need a speed. So we'll serialize this field so you can modify this directly in the inspector. And we'll call this will be a float, and we'll call it speed. And by default, I guess we'll set it to 3, because I think that's what I've got my character movement speed to. So we keep those the same. And I think that's all I can think of for the time being. So to start, I don't think we need our start function. Okay. So before we get ahead of ourselves, sorry, this is a pet peeve of mine, I just don't like those stock comments. I'm going to go into Unity, and I just saved this script. It's attached to the camera. It should pop up down here. So we need our character, drag our pirate ship in, it takes it, and then we'll go back into modifying our script. So in our update, we're going to basically need to check that the difference between the character's position and the camera's position is greater than a certain number before the camera starts to follow it. So I guess actually we're going to need another set of fields here, and these will be floats as well, and we'll call one X difference, and we'll have another one called Z difference. And the reason it's X and Z is because I've actually got this top down, so you can see the grid there, and I've got this actually set like the ground, so we're looking down on it instead of looking forward at like a standing up plane. So when something goes this way, if you look over here, you can see the position, the Z will change. If we go this way, the X will change. So we're going to be using our Z and our X. So we'll go back into our script here, and we're actually going to need to set our movement threshold as well, which is going to be how far away from the camera we want the character to get before he starts being followed by the camera. So these are going to represent how far away from the camera on the x-axis the character is, and how far away from the camera on the z-axis the character is. And this one, which is also going to be a float, and we'll call it movement threshold, is going to be how far from the camera the character can get before the camera starts to follow. So we'll go ahead and we'll set this, I guess, just for shits and giggles, to 3 as well. So then I think we're ready to go ahead and start coding this. So in our update, we're going to want to say if character transform position x is greater or equal to movement threshold, or just a second here. We're going to actually, this is going to be a really long if statement if we do it that way. So on our update, we're going to actually set our x and z difference and use those. So we're going to say x difference equals character transform position x minus the camera's transform position x. And the reason we don't have to specify what transform we're using is because this script is attached to the camera. So it's actually the same as saying this dot transform, where this references whatever object this script is attached to, but this is actually redundant. We don't need that. So we can just say transform dot position dot x. So this is going to give us the difference between the character's x position and the camera's x position. And actually, this isn't going to work perfectly, so we're going to just work with this for now to show you why this isn't going to work perfectly. But we'll say for now, if x difference is greater or equal to movement threshold, then we're going to want to set our move temp equal to the character's position. But we're also going to always want our move temp to be a little above the character. Otherwise, our camera, when we move it to move temp, is going to be in the same position as our character, and that's not going to work well. We need it to be up a little bit in order to still be able to see the character. So in any case, we always want the move temp variable's y-axis to equal at least 1, because we're using an orthographic camera. It doesn't matter if I move this up or down, because you can see in the game view that it stays the same unless I bring the camera down below the position of the ship, because it's an orthographic camera, as you can see over here. If we go perspective, it makes a difference. But orthographic is basically, it just renders everything in 2D, even if it's a 3D object. Distance doesn't matter. So there you go. So we're going to always want it to be at least a little bit above our pirate ship in this case. So we'll set it equal to 1, where I think the pirate ship is 0 or something. Will be 0. 0.1, 2, 3, 4. There we go. Just enough to bring it up over the thing. Okay, so we'll go back into our script. And so move temp is going to equal this. And we're going to always want to, if the difference is greater than movement threshold, we're going to want to, actually, we should do this here. Apologies. I'll put that there because we're going to want it to do that before we move the camera. So we'll say transform position equals, and we're going to use function of or method of the vector3 class, and it's called move towards, which basically just moves whatever object you're calling this function for towards a certain location. So over here you can see how to use it. So the first parameter is the current position, which is going to be transform position. The next one is going to be the target position, or the position you want it to move to, which is going to be move temp. And the next one is a little ambiguous. This isn't very clear. Float max distance delta, and actually this is going to work out to pretty much just be our speed. So we'll go ahead and we'll call this speed times time dot delta time. If you're not familiar with time dot delta time, that basically returns the amount of time between frames. So when you multiply a speed by that or anything by that, that will keep a smooth, consistent speed or any kind of transition that you're doing across all frames. Because 1 second you could have 50 frames per second, the next you could have 60 frames per second, and using time.delta time prevents a jumpy or inconsistent transition, because frames occur at different rates and update happens each and every frame. So all of this code will be executed each frame. So that's why we use time.delta time. So anyway, we've got some code here that should work to move our character when it reaches that threshold, which right now we have set to 3. So we're not getting any error messages down here. Just this is for one of the assets, not related to this, but no error codes. So we'll go ahead and run this. We'll see if this works. So it's not working. And we can have a look and see why. So we'll change this to be our 2x3 so we can watch everything that's going on. So our pirate ship, we'll see the position of the pirate ship. So the X is going to change here. We can see our X is changing. And it's going in the negative direction. Okay, so what we're doing is we're subtracting the pirate ships, or we're subtracting the camera's X position from the pirate ship's X position. And that is basically just always going to give us a negative number for the time being, because the camera's position is 0. So if we're subtracting 0 from a negative number, it's always going to be that same number. So we're never going to reach our movement threshold of 3. So what we're going to have to do is watch when this becomes greater than 3, and then it should start following. So right now there's obviously a flaw in our code, and I anticipated this. I just wanted to show you why we're doing it a certain way. So if we move the other way, we can see the X difference then becomes a positive value. So it should work when we move to the right. So there we go. We can see the camera clearly following the ship. So we're actually going to change this aspect and maximize it when we play it, just to have a better look at how this is working. So there we go. And I think that the pirate ship speed must actually be a little higher than the camera's. So before we go ahead and modify the script anymore, we'll change the speed on this pirate ship, or actually we'll change it on the camera, because I think that speed on the ship is pretty good. So we'll set them both equal to 5, so then it shouldn't go out of the bounds. See, it's not creeping towards the edge. And actually, I don't think that dead zone is quite big enough, so we'll crank up the movement threshold as well, and we'll say we'll double it to 6. So now it should let the ship get closer to the edge of the play area before it starts to follow. So before it was somewhere around here, and now it's a little bit further. And you can play with that and make it a little bit farther, but right now it only works for the X axis when you're going right. So we're going to go ahead and we're going to add a little bit of code to make it work for the Z axis as well. And then we're going to fix that problem with the negative number. So if X difference is greater than or equal to the movement threshold, or Z difference is greater than or equal to movement threshold, then we'll do it. So this should work. Whoops. Or, wrong button there. So that double pipe means or. So if either of these conditions are true, we're going to want to execute this stuff. So that's going to make the camera move towards the position of our character. So we'll save this, try it again, and it should work at least in one direction for the z-axis. So we still get our functionality for it going right, and we'll actually look at this in this view so that we can still see our stats over here, the x and z difference. So when it becomes greater than 6, it follows, because remember we changed the movement threshold to 6. If we go up, our z difference isn't doing anything, and I think that's because we forgot to add the code to set the z difference. So yeah, we did. So basically we're just going to copy this over and replace every occurrence of x with z, because it's essentially the same code. Save that again, run it again, and if we watch over here, our x and z difference should change now. So our z difference as we go down becomes negative, and it will never move the camera when we do this. But if we go up and this value becomes greater than 6, the camera should start to follow. So there we go. Same effect for both directions, as long as one of them is greater than 6. Okay, but like I said, it only works in one direction. If we go down or we go to the left, it doesn't do anything for us. So we've got to go ahead and add one more check to this simple script, and that will fix that problem of the negative number. So if you're familiar with absolute values in math, you might be tempted to think that you can use that, but that causes some problems when you're, in this example, our movement threshold is 6. So when you're between either -6 and +6 on the x or z axis, that's actually going to cause some problems if you use absolute value. So this is a bit of a workaround for that. So we use another check, and we'll say if character transform position dot x is greater than the camera's transform position x, then we're going to want to set our x difference equal to the camera's position, or the character's position minus the camera's position, because the character's position in this case will always be greater than the camera's position, and therefore we'll always get either a 0 or a positive number, so we won't have any more of that negative number stuff. And then we'll say else, so if it's not greater than, I don't know why this is doing this to me, if it's not greater than the camera's position, then we'll flip it around and we'll say that x difference is equal to transform dot position dot x minus character transform position x. So that will hopefully give us always a positive number, no matter which direction we're moving on in the x-axis. So we'll go ahead and save that and try it in Unity again, and we'll watch our x difference down here. Z isn't going to change any yet, but our x difference is going to be a little different now. So if we move left, we should get a positive. Let's just check. We go right, and we still get a positive number. We go left, and there you go, we get a positive number, and it's following now as well in the other direction. So we're going to basically just copy that little bit of code for the x difference, and we're going to replace it with, or replace the z difference one with this. And so you can see there's quite a bit of repeated code here, so maybe if you wanted, you could do a simple method and just pass it either the x or z axis somehow, but we're not going to get into methods and stuff like that. Maybe I'll do some tutorials later on, just general coding stuff, but for now, I'm just going to do some specific things because it helps me learn, and people like to learn how to do little tricks like this. So now that we've got that script done, so we've got our x stuff working, and hopefully, oh look at this, forgot to change that, good thing I caught that, or we'd be debugging. So we've got this one for both the z and the x, and everything else is the same. So now it should work when either the x or z is greater than the threshold in any case, whether we're moving in a positive or negative direction on the axis. So I'm pretty confident this is going to work. So we'll go ahead and maximize. And it's following that way. It's following that way. Just going to change this here. It's following that way. It's following that way. And actually, I know there's going to be a problem if we move on 2 axes at the same time, because it's going to actually be moving a little bit faster than that 5 speed that we've given it, because it's moving in 2 directions at the same time. So there is a little piece of code that you could do to make that, to correct that. You'll see what I'm talking about here. The ship is creeping towards the corner, and so it'll actually allow you to go off the screen. There is a workaround by checking if it's moving, if you're moving on 2 axes, but you can solve this problem by, for example, setting the size of the camera to be a little bit larger. So, I mean, your player still could, in theory, move off of the screen if they really, really try, but they may not. But if you can't figure out how to do that on your own, a great way to learn is to try to figure out stuff on your own. But like I said, if you can't figure out how to fix that problem, let me know and I'll try to give you some pointers. But I encourage you, if you're interested in this script, to try to figure that out for yourself, how to get it to always maintain constant distance instead of allowing the player to reach a corner like that. You can see the distance between the ship and the corner is becoming less and less, and so that's a problem. So yeah, I challenge you, I guess, as a assignment or something, if you're interested in trying to figure out how to solve that. If you can't, you get stuck, you need some help, let me know and I'll see what I can do. But there's the framework for that anyway. Hopefully you can find some use for it. And yeah, I guess I'll see you guys for the next video. And by the way, if you have any requests for something you might want to learn in Unity or programming in general, shoot me a message or a comment. I'd be happy to try to make a video about that for you, see if I can't teach you a thing or two. And yeah, thanks for watching. See you next time.